number of cycles. Remember I said you need an event and you need a duration. Okay? So frequency is the number of cycles per second. Frame rate is the number of images per second. Okay? Yes, ma'am.
Can we say about the frame rate? It's the how fast the pictures created?
Yeah. Yeah.
Okay.
You can say that. You can say that. Absolutely. So that's frame rate, guys. So this is an example of frame rate. I'm really big into TVs and stuff like that. When I go buy a new TV, I'm looking at all the specs. I need to know the hertz. I need to know the HDR. I need to know the frequency at which my images are being acquired. Y'all remember when the new TV started coming out, when we first started getting 4K, when you used to look at the TV, now we're used to it, we're all used to it. But when we first used to look at the TV, it used to look like it was moving funny, right? I don't know if y'all remember this. The TV used to look like it was moving funny compared to like a tube TV, because that technology changed really fast. You know, I grew up in a house where my grandma had the big wooden TV on the floor, you know, and so to now to have digital TVs, LCD TVs, and you know, you can see so much detail, you know, it's just amazing to me. So this is to show how different frame rates are. So when you are able to acquire images at a faster rate, it looks a lot smoother. That's why when I said the TV looked funny, because it looks like the person's coming in your house actually when they start moving, compared to like, and those old TVs were like 60 hertz, like this TV right here, like this one right here. But now we have 240 hertz. I think we even have, because now we have 4320p TVs now. We have 8K TVs now. I don't know if y'all are all shopping over Christmas, but now we have 8K TVs. So now our TVs are even like 2 times better. I remember when 720, oh my God, we got a 720p, like that, we kill it, you know, but now we have 2360, okay? So you're able to see that at 60 hertz, it's kind of jumping, like, look like an old Nintendo game, right? And now we have, with 240 hertz, you can see it looks a lot smoother. The same event is happening. This event is the same thing. I don't know if this is a ninja or something jumping off of a cliff. I don't know what that is, but you can clearly see that when the images are acquired a lot faster, you can see every single motion, every single movement of that image, instead of it looking kind of spotty or robotic, like it's playing Tetris or something like that. Okay, but I like this image right here to kind of explain, you know, low frame rates versus high frame rates. We have high frame rates. It looks like it's moving in real time. Looks like it's moving. It's like our ultrasound system. You know, looks like it's moving in real time. Like I compare that to, remember I said the more applications you put on your ultrasound system, the slower it moves. So when you have pulse wave Doppler on and you have color Doppler on at the same time on top of a 2D image, your frame rate slow down tremendously. And sometimes you can even see that the images aren't being acquired as fast. Okay? To the naked eye, sometimes we can't tell because sound is still moving faster than we can see. All right? So, temporal resolution, guys. Again, temporal refers to time, right? Specifically refers to accuracy in time. All right? Okay. More specifically, it's the ability to precisely position moving structures from instant to instant, such as the heart, such as the fetal heart when we're trying to get an MO, right? So if we weren't able to identify these structures accurately, then we wouldn't be able to get accurate fetal heart rates. Okay, our fetal heart rates wouldn't be accurate if the ultrasound system wasn't able to calculate those movements accurately. Okay? So that's what we're kind of calculating, right? We're calculating the movement versus the time. So that's how we're able to calculate the heart rate itself. Okay, so temporal resolution pertains to accuracy in time. All right. Again, and I made these like flashcards again. All right. So temporal resolution is great. It's great when the system produces many frames per second. Yeah, that's what, remember, temporal referring to time. So yeah, we're gonna have increased temporal resolution when we can create a lot of image in a short 1 second. Okay? Bless you. But however, temporal resolution is substandard when it produces fewer frames per second. Okay. So we want high frame rates if we're trying to create an ultrasound movement. Okay. We want high frame rates. We're trying to create an ultrasound movie. Okay. All right. Temporal resolution. The reason we have to talk about frame rate so much is because temporal resolution is determined by the frame rate. Okay. So we have a high frame rate, then we have high temporal resolution, like I just said, and vice versa. If our frame rates are low, we have low temporal resolution. That's a direct relationship, right? That's a direct relationship. Temporal resolution also has units of hertz. Okay? Also has units of hertz. Okay? Any questions on temporal resolution? We're good? All right. So clear? You can see the hertz right here. So this 240 hertz has a higher temporal resolution than the 60 hertz. Okay. So let's talk about TFrame versus frame rate. TFrame is the shortened version of just saying the time it takes to make one frame. Okay. TFrame is just a shortened version of saying the time it takes to create one frame. Okay. TFrame and frame rate are inversely related. In fact, they're even reciprocals, meaning that when I multiply my TFrame times my frame rate,
equal 1.
is going to equal 1. Okay? So they have that special relationship. What else has that special relationship, guys? Frequency and period. I told you I'll never let you guys forget. I'll never let you guys forget. Y'all gonna pass on the first time. I'm gonna make sure. Okay? So yes, just like frequency and period, they have that special relationship where they're inversely related, but they're also reciprocals. Okay? So let's do an example. So an ultrasound system creates an image in 1/10 of a second. God, these are the easiest problems to get on the test, right? You just know you just got to take it from a fraction to a single number. But so ultrasound system creates an image in 1/10 of a second. The frame rate is 10 frames per second or 10 hertz. We get that? Okay. At the time it's needed to make each image decrease, the frame rate increases, right? As the T frame decreases, the frame rate is going to increase, and vice versa. Okay? We're good on that relationship?
So when it says normal, that means one frame it takes 10 seconds?
No, 1/10 of a second.
1/10 of a second?
0.1 second. It takes to create one image.
One image.
Mhm.
And then the other one, T frame.
That is the T frame.
The frame, how many frame hertz?
10 frames per second. If I'm creating an image in 1/10 of a second, that means I'm creating 10 frames per second. You got it? So if I'm
Is that similar when you hit the button too fast or too slow? But when you hit too fast, then less frame rate than when you hit it slower?
I really think that it does have to do with how quick you're hitting that button. Does change the frame rate, but also how long you've been off of the freeze button can also change that as well. But if you hit it fast, you are gonna have less frames than if you I don't know why that's kind of crazy that it does that. But if you tap it, you will have more frames.
Mm-hmm.
You have more frames. That's true. That's true. Okay. So
So
guys.
just a second. When we say frame rate, that is the speed of the image
No.
or the time of because I'm
Frame rate
confused why
is-
they have time frame or T frame and why they have frame rate.
Because they're reciprocal. They're basically the opposite. T frame is just saying that how much time it takes to create one single image, one single frame. Frame rate is the ratio or the amount of image that can be created per second.
1 second.
Isn't the same thing? It's just the reversing? Like
Absolutely, that's what I just said.
Yeah.
Absolutely, just the reverse. Just the reverse. Okay, really, real quick. Any questions on frame rate and temporal resolution, guys? Any questions on the relationship between T
Explain
frame?
the relationship again.
Between what?
The resolution and the frame rate.
Frame rate and temporal resolution have a direct relationship, right? If my temporal resolution goes up, my frame rates are gonna go up. If my frame rates go down, my temporal resolution is gonna go down.
The
Okay?
faster, the better temperature.
Exactly. The faster we're acquiring the images, the better the temporal resolution is going to be. Temporal resolution is dealing with time. Temporal resolution is the ability to create, to image move structures that are moving from instance to instant.
But it's better to have more frames in that.
It depends. It really depends on what you're trying to accomplish. It's better if I'm trying to create an ultrasound movie, but if I need better detail, if I need, we're gonna talk about it in a minute. But let's say I needed better detail with my lateral resolution, and I needed more focal zones, right? And I'm just trying to image the gallbladder. But then I don't care about an ultrasound movie when I'm just trying to get a great image of the gallbladder. Image meaning one picture. Okay? I care about temporal resolution when I'm trying to look at a moving structure, such as the heart. That's when I want it optimal. Absolutely. That's when I want it to be optimal. That's when I want temporal resolution to be optimal. When I'm looking at something that's moving. Okay. Any other questions?
So did you say temporal resolution and frame rate are directly related?
Absolutely. You can say that, definitely. Definitely. Temporal resolution and frame rate are directly related. Temporal resolution is determined by the frame rate. Temporal resolution is determined by the frame rate. That's a direct relationship. So that I can also say temporal resolution and T-frame are inversely related, right? I can say that same thing. Just like T-frame and frame rate are inversely related. They're reciprocals. Okay? Remember, guys, it's all about relationships. So if you understand the relationships, it don't matter what number I throw at you, what group of numbers I throw at you. If you understand that how this is related to this, then you will be able to work any problem out, no matter what the number is, because you're going to know whether something's going to increase or decrease, right? So I want you guys to really focus on understanding the material, not necessarily just the numbers. The numbers are just examples, okay? But understand how one thing is affected by something else, okay? So I can actually write on this board. I'm just going to shorten it. FR, frame rate, temporal res, and I can write T-frame. Relationship, if the frame rate goes up, temporal resolution going up, T-frame is going down. Okay? So remember that relationship right there. That's like the summary of what I've been talking about the past like 15 minutes. That's the quick summary of it right there. That's the relationship right there. Okay? Ooh, who hair is this? Okay. Any other questions on temporal resolution, frame rate, and T-frame? No questions?
Nope, hold on.
Okay, so I'm gonna keep moving, guys. Now we're gonna talk about the system settings that determine frame rate. Okay? System settings are the sonographer control settings. Things that us as a sonographer, we can do to change the frame rate. Okay? Multiple things we can do is about 4 of them. Okay? Probably more than that, honestly. But when we're talking about temporal resolution, we're talking about these 4 things right here. Or
What are
these 2 things right here.
Yeah. We can just change the depth.
That's one of them. That's one of the ways to change frame rate. So the 2 sonographer control settings that determine frame rate are going to be the imaging depth and the number of pulses per in each picture. Okay? The number of pulses in each image. Remember, like I said, if I have multiple focuses, if I have 3 focuses versus 1, it's going to take my image 3 times longer to acquire, right? Because I have to send out a scan line for each focus, right? At different depths. Remember I had that illustration of 3 focuses. It's going to send out 1, it's going to go back, send out another one at medium depth, it's going to go back, send out another one at a deeper depth, it's going to go back. Then it goes to the next scan line. Y'all remember that illustration we had? When I was talking about, I think that was chapter 12. Yes, ma'am.
So number of pulses means PR.
No, the number of pulses take to create the image. Basically, the number of pulses, because remember, images are created by a sector, right? A sector or a fan shape is going to create our image.
So that's the transducer?
That's the transducer. However many however many scan lines it takes to create that image from whatever the shape of the transducer. It can be a linear, however many it takes. Remember, with a linear sequential, it's gonna fire some and not all, right? So however many it's gonna use to create that one frame, that depends on the transducer. But also the number of pulses in each picture, because I can change the number of pulses. We're gonna talk about it, and I think you'll understand it more when I get into it. So 2 things that the sonographer can change that can control frame rate are gonna be the imaging depth and the number of pulses per image. Okay? Don't freak out on it yet, guys. Let me get to it, and I promise it'll clear. All right. So let's talk about imaging depth first. Imaging